mini lesson today. Like when I say mini, I mean like that's the amount of notes we take today. Because today, the only thing we're doing is a proof. You don't have to sound so tortured. Exactly. Except real excitement. Don't worry. We'll do a lot more proofs later in the trimester. Today it's only one proof. And I don't expect, when it comes to the proof that we do today, I don't expect under any circumstances that you take this proof and create other proofs like it. Because there aren't other proofs like it. Today's proof is the only proof that fits for what we are doing today. And what it is that we are proving today has to do with the fact that yesterday when we started talking about law of cosines, I'm willing to bet that at least a couple of people, when I started to write down the formula for the law of cosines, all of a sudden something else popped into their brain. When I started writing c squared equals a squared plus b squared minus, now I could keep going, but what's the first part of that look like? Pythagorean theorem. Pythagorean theorem is a special case of the law of cosines. That's what we're doing the proof of today. Now, when you guys have run across proofs in the past, with the exception of FSTA, when we did one proof there, okay, we did 4 proofs there, I guess, but when you guys did proofs back in geometry, you did what was known as a 2-column proof most of the time, or for some of you, it was flow proofs. In either situation, that's not actually how proofs are typically done if you move on with mathematics. If you continue to go through math and where you're getting into the calculus or beyond calculus, more commonly, it's not in calc very often, the proofs that you come across here are just going to say something like this. It's not going to be the situation like in geometry where it says, given, insert information, prove this. On these ones, they're just going to give you a sentence. Prove, in our case, that the Pythagorean theorem is a special case of the law of cosines. And from there, with that information, you then have to set up the information that leads us into things. So we are trying to prove something to do with Pythagorean theorem. What do you know about Pythagorean theorem? A squared plus b squared is equals c squared. So that's what we're trying to get to. What else do we know? That you use it on a right triangle. And specifically, you can only use it on right triangles. Now, that is where Pythagorean theorem differs from the law of cosines. Law of cosines can be done with any triangle. So that is going to be some of our startup. That's going to be where we begin this process. Is what is different about it. And the difference is that Pythagorean theorem can only work with right triangles, which means the first part of my proof that I have to do is I have to establish that I'm working with a right triangle. So, to do that, I do something like, say, let triangle ABC be a right triangle. Now, I need to get a little bit more specific than that, because if I'm going to plug things into law of cosines, which is where we're going with this, generally speaking, these proofs, you establish what you have at the beginning, and then you start plugging things into the formula or into what you know. we can't just have a right triangle. We have to know what is located where on the right triangle. Now, if the Pythagorean theorem is a squared plus b squared equals c squared, we're making something a right triangle. What makes something a right triangle is it has that right angle. We have to establish where the right angle is located. Is the right angle located at angle A, angle B, or angle C? Why C? Because the right angle needs to be opposite of the hypotenuse, and the hypotenuse is where we put C in Pythagorean theorem. So not only do we need to let triangle ABC be a right triangle, but we need to have it be a right triangle such that angle C is a right angle. So we need to establish that piece about it as well. We need to be specific in what we know about it. Once you have that down, we can start plugging things in to our law of cosines. Now, the law of cosines in the form that I gave you is c squared equals a squared plus b squared minus 2ab cosine of angle C. That's what we're using to do this proof. So that's what's established in the setup and what it's telling us to do. And we now can plug things into that formula. Now, we don't have a whole lot of information that we can plug into that formula because we are making triangle ABC just be a right triangle. We know nothing about that triangle other than it has a right angle at angle C. Isn't angle C in the law of cosines? What's a right angle? A 90-degree angle. Okay. That's what I can plug in. C has to be 90 degrees. Everything else did not change. I have trig of a number right now. I have cosine of 90. What is cosine of 90? You could do this on the unit circle. You could do this in a calculator. Doesn't matter. Cosine of 90 is 0. So I simplify cosine of 90. Now this is a proof, so I do not skip steps. So this just becomes times 0. C squared equals a squared plus b squared minus, what is 2ab getting multiplied by 0? It's a proof. I don't skip steps. What does minusing 0 do? C squared equals a squared plus b squared. That's the Pythagorean theorem. Therefore, we are done. That's a little symbol that goes in the corner of many proofs that indicates that you're done, by the way. You don't have to put it. It's not the end of the world if you don't. But that's what that little symbol is. That, or you'll see QED, quite easily done. I don't know if that's actually what it's supposed to stand for, but that's what a lot of people write. But law of Pythagorean theorem is a special case of law of cosines because of the fact that it's got a 90-degree angle. If you plug 90 in, it makes that part 0.